Okay, uh, thank you for joining in today's session. So we've now come to our second tutorial for our Unit 10 for analytical impact through data visualization. So what have we covered in our previous tutorial? We've looked into understanding the importance of communicating results in a clear and compelling way for our data visualization report. So what we're going to cover in today's session, we're now going to understand a range of graphical representation and data visualization that are appropriate for analysis. So we're now going to have two mandatory learning outcomes, and there are no merit and distinction for this session. So let's get into our presentation. So when it comes to understanding a range of graphical representation, we're now going to look into the different type of visualization that will now serve various purposes depending on the nature of the data and the insight source. So some of them could be bar chart, where with bar chart we now use a rectangular bar to represent our data, our values. So each length of each bar is proportionate to the value it represents. So here we have use and best practice for bar chart, where with use we are going to comparing categorical data, going to be showing frequency distribution and display data changes over time when the bar are used in a temporal sequence. With the best practice, this will now ensure that bar are of equal width and space evenly. Also, we're going to use zero baseline to avoid misrepresenting differences. And lastly, we're going to label axes and bar clearly. With linear graphs, we're now going to use points connected by lines to display our data point in a sequence, typically over time. Benefit of our linear graph tracking changes over period, comparing multiple data series, identifying trends and patterns, while the best user consistent scale of axes, avoid clutter by limiting the number of lines on a single graph, and highlight key point or trend with annotations. If we have pie charts, we're now going to display data as a slice of a circle, with each slice representing a proportion of the whole. The use of pie chart, we're now going to be showing the composition of the whole, comparing parts of single data series. Best practice for these are going to limit the number of slices to avoid clutter, ensure the sum of the slices is equal to 100, and use distinct colors for each slice. Histograms, these are similar to bar chart, but they're used for continuous data divided into bins or intervals. So the use of this is to display distribution of the data set, identifying the central tendency, spread and skewness of data. Best practice, we're now going to choose appropriate beam size to reveal the underlying distribution without over smoothing or over complicating. So we're now going to also label axis clearly and provide the scale. Scatter plot. There is a use of Cartesian coordinates to display value for typically two variables, showing how one variable is affected by another one. This used to identify correlation or relation between variables, detecting outliers and patterns. Best practice for this is to use a consistent scale on both axes, avoid overlapping point by using transparency or jitter, highlight trends or pattern with them linear or best fit. Box plot. With box plot, we're now going to summarize data through the quarterlies, highlighting the meridian, lower and upper quarter lines, and potential outliers. Benefit of this, we're now going to comparing distribution across different categories, identifying the spread of central tendency of data. Best practice, we're now going to clear label the quarterlies and meridian, use box plot side by side for comparison between categories, and also indicate outliers explicitly. Heat maps. With heat maps, we now use color to represent values in the matrix format. Background intensity will now indicate the magnitude of values. The use of heat maps is going to be showing the concentration of value across two variables, identifying patterns and correlations. Best practice for this, I'm going to use a color gradient that provides a clear distinction between high and lower value. Include a legend to explain the color scale. Avoid excessive use of bright colors, which can now be overwhelming. Tree maps. This will now display hierarchical data as the data of nested rectangles, with the size and color of each rectangle representing different attributes. The use for this is for showing composition of hierarchical data, comparing the proposition and subcategories within a larger category. Best practice for this, we're now going to use a consistent color scheme to represent categories. Label rectangles clearly or use interactive features for detail of demand. But we're also going to ensure that hierarchy is easily discernible. So to conclude, we can now set up bar chart, linear graph, pie chart, histogram, scatter plot, box plot, heat maps, and tree maps. Each have distinct features, and they're all suitable for different types of analysis. So in our 2.1 learning outcome, we're going to compare the appropriateness of using different chart and plot types for continuous versus categorical data variables. So we now know that by choosing the correct chart or plot, this will now be very important because it's going to give us accurate representation of our data, and also it's going to give us a different type of data which is required for different visualization techniques. So with our upcoming slides, we're now going to compare the appropriateness of various charts and plots for our continuous categorical and summary data, where we're also going to be considering aspects such as hashes, independent versus dependent variables, also appropriate min and max value, and markers, and label with appropriate numbers format. So charts for time series data. When it comes to time series data, this involves the observation records at a specific time interval. So the primary focus is on how data point changes over time. With a linear graph, this ideal for time series data, and they clearly show trends, pattern, and fluctuation over time. The x-axis typically represent time, while the y-axis represent the variable being measured. With axis consideration, this can be independent variable, such as time, plotted on the x-axis, dependent variable, measurement, plotted on the y-axis, min and max value, which sets the cover of the entire range of data point to avoid truncation. Markers and labels, this will now use appropriate time intervals, and these are now going to ensure the label readable and not plotted. Area charts, these are similar to graphic charts, but they fill the area below the line. Useful for showing cumulative data over time. Charts for categorical data. When it comes to categorical data, this will now represent disparate groups of categories. These focus on comparing these groups. When it comes to appropriate charts, we now have bar charts, which are effective for comparing the size of frequency of different categories, and categories are displayed on the x-axis and the values are displayed on the y-axis. Axis consideration, we now look into independent variables, which are now plotted on the x-axis, and the dependent variable, which are plotted on the y-axis. Minimum and maximum values, we now start from y-axis at 0 to accurately represent differences. With pie chart, this will now show the proportion of each category relative to the whole, suitable for visualizing parts of the whole for a single data series. Chart for summary data. With summary data, we're now going to provide an overview of data distribution or aggregates such as means, median, range, and standard deviation. with histogram. This will now show the distribution of continuous data by grouping data into bins. General consideration for hashes, markers, and labels. When it comes to hashes, these are independent. This could be independent or independent variables, where we've already mentioned that with independent, we now have a clear distinguished independent variable, typically on the x-axis, while the dependent ones will now be on the y-axis. Markers and labels. When it comes to number format, we'll now use appropriate number format. For example, when it comes to currency, percentage of date, this will now going to enhance the readability and interpretation. Labels will now ensure that all labels are clear and not overcrowded, with hashes status, which would clearly indicate the variables and unit of measurement. So we can now say that linear graphs and area chart are suitable for time series data, bar chart and pie chart, which are best for categorical data, and box plot and histogram are ideal for summarizing data distribution. So we're now going to compare the appropriateness of using different chart and plot types for time series data. So we know now that there are different types of chart and plot which can be used for representing data, where each with its specific appropriateness, depending on the nature of the data and the analysis required. When it comes to column and bar graphs, we now use summary data, vertical versus horizontal, categorical, normal, and ordinal variables. With the first one, these are suitable for displaying some summary data such as totals and average. Vertical is typically used to show changes over time. And lastly, with categorical, nominal, and ordinal values, these are going to be effective for comparing categories or ordinal data. So we do have an example for each of them, where the use of vertical bar chart, bar graph, this is used for monthly sales revenues of a company. With the horizontal bar graph, this will now used for ranking a customer satisfaction score across different departments. Stacked column chart will now show the breakdown of sales by product categories for each month. And with a 100% stacked column chart, we're now going to display the percentage contribution of each product category to total sales each month. With linear graphs, we're now looking into time series data, continuous values, where the first one is now ideal for showing trends, patterns, and fluctuation over time. And the second one is used to track changes in continuous data over intervals. Pie and donut charts. These are now used for suitable for showing proportions over the whole. Examples for pie chart is when we're looking into market share of different companies in our industry. While with donut chart, this is the distribution of budget allocation across different departments in the organization. Scatter plot, the best use, the use for this is ideal for showing the relation between two variables, and it's also used to identify correlation and patterns. Examples for these, we're now going to use scatter plot for showing the relationship between advertising expenditure and sales revenue for different months. Bubble chart is a use to represent three variables where the size of the bubble indicates the value of the third variable, and this can be used for both types depending on data. So bubble chart will now show the relationship between GDP, such as x-axis, life expectancies on the y-axis, and population size, which will now be the bubble size for different countries. Surface or area chart is now used for three variables. They're also useful for showing cumulative data over time. So example for our surface or area chart is for showing the cumulative sales revenue over time for multiple product lines. Spider or radar graphs, these are now used to display multiple variables, useful for comparing multiple attributes. So example, with radar charts comparing the performance metrics with speed, accuracy, and efficiency of, for example, different software programs. Histogram is now going to show the distribution of continuous variable. With histogram group, data can now group data into bins, where bar charts will now compare discrete categories. Box and whisker graph. This will now summarize data distribution, highlighting median, quarterlies, and outliers. So example for box and whisker graphs is that with a box plot, we're now showing the distribution of monthly sales figures. With our whisker we're now going to be indicating variability outside our upper and the lower quartiles. Combo charts, these are now useful for displaying multiple data series within different unit of measures. Example for a combo chart is combination chart with bars which are going to be representing monthly sales revenues and lines showing average monthly temperature with separate y-axis for each data series. So to conclude, we now know that column and bar graphs are versatile for categorical and summary data. Line graphs will now excel with time series data. Pie and donut chart are great for showing proportion. Scatter plot and bubble chart will now reveal relationship between variables. Area chart will now show cumulative data. Radar graph will now compare multiple variables. Histogram will now display distribution. Box plot are going to highlight data spread and outline. And combo chart are useful for complex data comparison. So we now know that selecting the appropriate visualization will now depend on the specific requirement of our analysis and the nature of the data. So this was everything for our tutorial number 2. Is there any question?
Thanks, Victor. No, again, all very clear stuff, really. Just, yeah, the use of different graphs and stuff I use regularly, stuff I've done in previous qualifications as well. So, yeah, no, that was all great. Thank you.
Okay. Yeah, so since everything is clear, then I think this is everything for today, and I'll see you tomorrow.
Brilliant, that's great. Thank you, Victor. Did you say that you'd have a look at my Unit 7 today?
Yeah, I will have a look at it today, and I'll give you a feedback tomorrow in tomorrow's session.
Okay, brilliant. That sounds great. Cheers then.
Okay, bye.
Have a good day, Victor. Bye-bye.
Bye-bye.